In this video, let's look at Microsoft Phi-3-Vision 128K Instruct. So this is a lightweight, state-of-the-art, multi-modal model which is built upon datasets which includes synthetic data and filtered publicly available websites. Now, what can you use this Phi-3-Vision 128K Instruct model? You can use this for OCR, general image understanding, chart and table understanding. Since this is a lightweight model, you can use it in memory and compute constrained environments, latency bound scenarios. So this model is actually having 4.3 billion parameters. Let me go to that part over here. Right, 4.2 billion parameters. It contains an image encoder, connector, projector, and the Phi-3 mini language model. So it's a multimodal model. It takes as input text and image. It is best suited for prompts using the chat format. It has a context length of 128K tokens. I wouldn't go into the other parts like training time and other things. You can read it over here. This model has an MIT license, which means that you can use for commercial purposes as well. So let us try out this model. So I've created this Inference notebook over here. So for this, what I need to do is that I have to update the transformers installation, datasets and torch. So I have done that. So this is a GPU instance, and I'm using bfloat 16 over here. So it's a 4 GB model, so it takes close to 8 GB of GPU RAM. I'm using an L4 instance over here because I get close to 22.5 GB RAM, and when I do inference over images, I see a slow increase in GPU RAM. So this may not run on your T4 free instance, right? This particular notebook. So I am doing it on L4 instance over here. Right, so what I'm going to do over here is that first I have installed transformers, right? Then this particular model makes use of flash attention, so I have to install flash attention. That is done over here. Then the next step what we do is that we import an image, like from PIL we import image. From transformers we need to import auto model for causal LM and auto processor. And our model ID is Microsoft Phi-3-Vision 128K Instruct. And when I am creating the processor as well as the model, I have to say trust remote code is equal to true. And I have my Hugging Face token over here, right? I have to provide access to this Hugging Face token. So you can create an access token in Hugging Face to access models. So when I'm running this code, it asks for access token, and then I have to grant permission to access this particular Hugging Face token. So in this way, I have initialized my Microsoft Phi-3-Vision 128K Instruct model over here. Then this is the user prompt typically, which is user assistant prompt and then prompt suffix. Okay, so user assistant end. So basically, it follows a chat format. So this is how this is the prompt basically. All right. Now let's try try out on an image. Okay. So there is this particular image URL. So I'll show you this image now. So let's open up this image. So this is NVIDIA's data center revenue. Okay. So this is the image, right? So now we are doing image.open this URL, and then we are generating the inputs to the model using the processor, right, where we are passing the prompt. And if you look at the prompt over here, in the prompt we say like this, the image placeholder, image 1, okay, could you please introduce this talk to me, prompt suffix, which is we don't have a prompt suffix over here. Let's check it out again. Prompt suffix is end. Okay, so we have it. So that is your input prompt, image 1. Okay, this is just a placeholder to say that we are giving an input as an image. The user prompt is this particular user. Okay, so that is the user prompt. Suffix prompt is end, and assistant prompt is assistant. Okay, so in this way we now give the prompt. Could you please introduce to this talk to me, prompt suffix, which is end and assistant prompt, and this is the URL. we process the input image and the prompt using the processor, and that is the input to the model. We give it to the model to generate IDs, and from that generate IDs we are doing processor.batch decode to get our response. So here the response, it says that certainly NVIDIA is a global leader in advanced computing and AI technologies. It designs and manufactures GPUs, which are specialized hardware. So it is able to actually understand that image basically over here. Okay. So it gives out that as a response. And if you look over here, it took close to 12 seconds for this particular run for inference on this particular image, downloading this image and then doing an inference over this particular image. Right. Then another example which I thought of doing was like I wanted to, they claimed OCR performance over here, right? So they said that OCR is one of the use cases. So what I did was I took this particular image. Okay, this is an image of a restaurant menu. And then I wanted to get the price of milk over here. So for that, what I did, again, the user prompt is user over here. Image is the image placeholder for the image tokens basically, and then help me get the price of milk. That is what I've asked over here. The prompt suffix is that end and assistant over here. Okay, so this is the image. Again, the same process, we process the prompt and the image, and then we get the we give it the inputs to the model, get the generated IDs. From the generated IDs we can decode the response, text response. Okay, so once I do that, I was pretty surprised with the result over here. It says the price of the milk is 20 rupees 28.50. It has done an excellent OCR over here. See, 28.50. So the OCR performance on this image was excellent. Okay. So you can also give two images as inputs and ask like what is the difference in these two images. So here if you see in the prompt, you have image 1, image 2, placeholders for the image tokens. And so that the processor basically will process the image plus this prompt into your prompt which is given to the model. So here there are two images. So the images are this is the image 1, Arsenal Football Club, and this is the second image of Arsenal winning the your Premiership champion trophy. Okay, so the question is like what is the difference between these two images? So you can take two images. You can create a list of images over here, pass that list to the prompt processor along with the prompt, okay, and then get the inputs, pass it to the model, get the IDs, and from the IDs you do decoding and get the response. Let's see what is the response over here. So over here it says the first image shows a group of soccer players from the Arsenal Football Club posing for team photo with their trophies. Second shows from the same foot celebrating a victory with a large crowd of fans in the background. The difference in the two images, first image captures a moment of the team with their trophies, while the second image captures a moment of the team celebrating a victory with the fans. Okay, so here is the trophies and this is the victory basically with the fans, right? So it has done an excellent inference over here as well. So does it work for all cases? So let's do some more testing. So what I did was like I pulled out another image like this, which was NVIDIA's again share prices. And I gave this as input to the model and I asked like what is the price of NVIDIA share in the year 2022. Okay. So here the response it says that appears to be 4K, right? Based on this line chart. So 4K is somewhat average of this period. It's not really 4K, it's much more than that. But this is the kind of response I got over here, right? Based on interpretation of this graph. Then I tried another image. So basically I uploaded some images and like I uploaded this image and then I asked about this image, right? So here I've uploaded the image set of images over here. So, and I'm opening it over here and I'm asking like explain this image, right? So here the response it says that this image displays a mathematical function. Excellently it has done that. The function is presented in a black text box with white font. It represents a probability density function commonly used in statistics. X is the variable, mu is the mean, sigma is the standard deviation. So it has done all those, interpreted this image properly. Then I tried another image over here. So I passed this particular image and I asked like, what is this image again? So here it talks about this image properly. Chart is a two-dimensional scatter plot with a black background, two axes, support vectors, everything it says, and in the end it says that this chart is used to illustrate support vector machine classification model. Excellent results again. Okay. So in the limited testing of this particular model, I'm quite impressed with this performance. Then I gave another food image. Okay, so I gave this image and I asked like, what is this image? Here it went for a toss because here it couldn't identify. It says there are pieces of meat. There is no meat in this. It's just vegetables, rice and paneer, right? So if you look at this particular image, so if you see there is no meat. So here it says possibly pork and rice, and meat is pink, appears to be seasoned. There are diced vegetables. So here, green peas and beans and carrots it's identified, but there is no meat. And there is no white sauce, that is actually paneer. And there is no red pepper flakes over here. So yeah, so here the interpretation has gone for a toss. Okay. Then I gave this particular medical image and I asked like, this is an image of a handwritten image with a prescription, right? So here I asked like, what are the symptoms? Okay. So here if you look at, there is knee pain, aggravated insomnia, difficulty in ADL and all those stuff. So I asked like, what are the symptoms and next steps? So here it says, sorry, but I can't assist with that. Okay. But if I were to just change this and say, let's say decipher the handwritten text. Decipher the handwritten text. Let's see whether it's able to do it. Okay, so we have to wait for say 3 or 4 seconds for the response. Let's just wait for it. So with respect to performance, what I've seen is that in some cases it gives very good performance. In some unfamiliar data like this, probably it's going for a toss. Probably you can fine tune the model. Okay, so it's now completed it. Let's see the response. Let's print the response and see whether it is doing the handwritten data OCR. Okay, it includes various medical terms, BP, okay. BC, aggravated difficulty in ADL, DM plus hypertension, tendon, ROM painful, X-ray, handwriting is not clear enough to read all the text accurately, but it has done something. Okay. Something it has identified over here, aggravated sincere, difficulty in ADL, BL, knee pain. So some things it does properly over here. Okay. OCR text provided fills in some of the gaps. So it is not able to read all text accurately, but some of these things. Okay. So this was my limited testing of Microsoft Phi-3-Vision 128K Instruct. This seems to be a good multimodal model, and this is a lightweight model, so it can be used for certain scenarios. You can check out this model. I'll be sharing this particular notebook as well, so you can also try out inference on your images. So for your multimodal use cases, you can try out this model. They've also provided with notebooks for you to actually train this model. So maybe I'll make another video on how to train your multimodal model. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.